All right, so part 2, we are going to talk about another way to measure angles, all right? And the way that we're going to measure angles is called radians, all right? And a radian measure comes from basically the circumference of a circle formula, where you let the radius be equal to 1, and you can kind of deduce this, this way to measure angles that is independent of degrees. Because if you think about it, 360 degrees for a full circle, it's like, where does that come from? It's sort of an arbitrary number. But radians are tied to the circumference of a circle, which is in terms of pi. And so we're not going to get too far into radians here, but like where they come from. But I just did want to tell you that that's kind of part of it. Okay, so let's answer these questions here. So I've got the animation here. Sorry, this isn't the greatest way to organize this, but when the radian count is at radian 1, how many degrees has the point passed through? So let's look at if I can stop this video at the right spot here. It's a little bit easier on a computer. Okay, so there it's at 1 radian. All right, and you can see that it's at, I don't know, it's over 45, maybe it's about 50-ish degrees. Okay, so 50-ish degrees, 50-ish. When the point is halfway, what is the radian count? So let's let it go till it is close to halfway around. All right, I missed it a little bit, and it's hard to see there, but it's about 3.1 radians. And it turns out that's about it's going to be 3.14 radians, which is actually pi. So halfway around is pi. All right. When the circle has traveled all the way around, what is the radian? You can see there's a radian counter here in the middle. Okay, so we'll just kind of watch it go. When it gets to the 360 degree line, it is, or not line, but when it gets all the way around, it's at 6.25, which is 2 pi. Okay, so it's about 6.25, which is going to turn out to be 2 pi radians around. Okay, circumference of a circle formula, by the way, is 2 pi r. Okay, so if you let the radius be 1, c is equal to 2 pi, and that's also your radian count. Okay, so in other words, from that, if you let the radius be 1, then you can get that all the way around is 2 pi radians. All right, so here's how you convert from radians to degrees. So if 2 pi radians is equal to 360 degrees, and if you divide both sides by 2, you get that pi radians is equal to 180 degrees, and that's your conversion. Okay, that's how you convert between the two. So we're going to use that conversion and convert the following. So if I've got 225 degrees, here's how I'm going to write this, 225 degrees. I'm going to convert this just like I would convert any value to any other value. I'll put it on a line. I want to cancel out degrees, so I'm going to put 180 degrees on the bottom. And radians on, so 180 degrees is pi radians. So degrees over degrees, those cancel out. I'm left with 225 times pi radians over 180. To make that number nice, I'm just going to do 225 divided by 180. Turn it into a fraction, and then write my answer. So it's 5 over 4 pi radians. Okay, and that's it. So we can do one more. Let's do this negative one here. It doesn't matter that it's negative. The process is still the same. So this is negative 200 degrees. I'll put degrees here twice, I guess. So negative 200 degrees, and the conversion is 180 degrees, pi radians. Degree over degrees cancels. 200 over 180, so 200 divided by 180. Math, fraction, Desmos, you just click the fraction key. And I get 10 over 9. So this is going to be negative 10 over 9 pi. All right. So that's how you convert from degrees to radians. We can go the other way as well. So here I have pi over 12 radians. So I'm going to write pi over 12 radians times, and now I want radians in the bottom because I'm trying to cancel out radians and I want to end up at degrees. So pi radians is equal to 180 degrees. Radians cancel out. Pi over pi cancels out as well. So you end up with 180 divided by 12. So 15. This this ends up being 15 degrees. Okay. We can do one more. This one looks sort of scary and complicated, but it's not too bad. We'll do 7 pi over 5 radians. And by the way, this is a division symbol right here, this line, and then you just add in the time symbols, okay? So then I've got pi radians on the bottom, 180 degrees on top, radians cancel out, pi's cancel out, and I've got 7 times 180 divided by 5, and that'll give us the degrees, so 252 degrees. Again, 7 times 180 divided by 5, and so that gives me, I should have given myself more space here, 252 degrees. You might put this in your notes that you're doing 7 times 180 divided by 5 in the calculator, okay? And we're not doing arc length or area of a sector, so we're going to skip that this year. The formula is actually not too bad, just in case, I guess I should put this in the video in case we do it in future years. But if you want to know what the length of this arc is, that distance there, then you just take and multiply r, the radius, times theta. And this will only work if it is in radians. Okay, so that formula only works if it's in radians. But like I said, 2021, we're not doing arc length. So that is it for section 2.